Hello everyone. Today we will practice with the discrete joint probability distribution. The computer help desk receives X inquiries during the first hour and Y inquiries during the next one. The joint distribution of X and Y is given in the following table. So X represent the first hour and Y represent the next one. And X can take values from 0 to 2, and for the Y we have the same situation. Each one of these cells, they represent a probability. Now let's go through the questions. So can this table represent a valid probability mass function? So what are the conditions to check for a probability mass function, or in general probability distribution? So for that we should check that each one of these cells should be a probability. It means that the values they can get should be between 0 and 1 inclusive. So as you can see, for all of these cells, we have values between 0 and 1 inclusive, and there are no negative values and values more than 1. So the first condition is true, that for all of the probabilities that you can find in these cells, let's represent for X as I and J for Y, then in this case, all of them are between 0 and 1, and this is true. There are I and J, by the way, here as indices. So what about the second condition? Why is that? It means that for both I and J, when I get the summation of all of the cells, it should be equal to 1, right? It means that when you get the summation of all of these cells, it should be 1. So let's check. So we check it like this: 15% plus 20%. It means that you are checking one by one, you are adding them together. Then the last one will be 0. And if you check, you will see that they should be equal to 1. So 15 plus 20, 35, 45, 55, 75, 80, and finally 1. So the accumulation should be equal to 1, which is true. So the second condition holds as well. And you can say that this is a probability distribution. So when you want to write the answer for such questions, then you can mention about this part that for all of them holds. But if there is a counter example, if for example this one was negative 20%, then you say negative 20% was less than 0. So because of this is not a probability distribution. Or for example, here, if I had the value 2, then you would say 2 is more than 1, and this is not a probability distribution. And if the summation is equal to 1, just by mentioning this part and showing the trend like this, you start from the first and second values. And it's okay to put 3 dots here so that we understand that there is a trend. It means that you are checking for all of the cells. And the last one. So whenever you want to use 3 dots instead of writing the whole thing, write the first and second component and the last one so that we understand what's the trend. And as soon as you show that this is equal to 1, then that's the final answer. But if it is not equal to 1, then you can show it like this and find the summation of them and show that this is, for example, 1.70, and this one is not equal to 1, and this is not a probability distribution. Okay, so let's go to the second question. Second and third question are very important in order to understand what is lowercase f, what is capital F. So for lowercase one, this is a probability distribution, and we can call it also as probability mass function. And this is a discrete case, by the way, don't forget. Later we will talk about the density function, which is related to continuous ones. And when we talk about capital F, it means that this is a cumulative version of that. So if we ask you what is F11 and capital F11, these two are not necessarily equal. Okay, we should be careful. So for this question, question number 2, we are asking for F12. So how to calculate F12? It's very easy. It means that for the first component, this is corresponding to X, and for the second one, it corresponds to Y. Okay, so it means that X is equal to 1 and Y is equal to 2. We are looking for the intersection of them. So among 2 and among 1. What's the intersection? This is 20. So the answer is 20. Very easy, right? So 20% is the final answer. And let's practice with other cells too. Like, what's this probability? Let's say 1 and 1. What about this one? 1 and 1. So this is 0, for example. What about, for example, let's say -1 and 2. What about this one? Okay, as you can see, X can get its value from 0, 1, 2. We don't have -1. So right away, whenever we are asking you about the probability, which is impossible, what's the final answer? You shouldn't write empty, for example. This is not the correct answer. You should say 0. The probability of something impossible is 0. And if it is 100%, then in that case, you should say 1. Okay, so also practice with such cases to know exactly how we deal with that. When this is impossible, then that's how we show them. And by the way, we show them like this, but also, as you know, we can ask questions like, what's the probability of X equal to 1 and Y equal to 2 at the same time? This is exactly the same way we can ask questions like this one. There's no difference between these two, okay? So practice with such formats as well. Or maybe we can practice very fast together here. Like, what's the probability of X equal to 1, Y equal to 0? What's the answer? So X is 1, Y is 0, so 10%. Okay. What's the probability of X equal to 1? That's it. Marginal probability. So doesn't matter what's the value of Y. When X is equal to 1, what's the probability? So it should be the summation of them. You see, guys? So this is 30%. 10% plus 0 plus 20%, so 30% is the final answer. So you can practice with them like this as well. If you have any questions about them, please don't hesitate to ask me about them. But what about the cumulative version, like capital F11, as we asked in the third question? What about this? It means that you should consider all values less than 1 as well and add all of them together. So when we talk about F11, it means that if this is 1, we should cover 0 as well. And for Y, it's the same. So 0 and 1. So these cells should be considered. So the summation of all of them. So first I write the probability mass function of them, like, for example, F0, 0 plus, this is a lowercase, by the way, plus 0, 1 plus 1, 0. So all the possibilities, which is less than the value that we given you and also equal. So F1, 1. So as you can see, these two are not necessarily equal because there are some other probabilities that we should consider. So what is F00? This is 15%. What about 0, 1? This is 20%. What about 1, 0? 10%. And 1, 1 itself is 0. So finally, this probability should be the summation of them, which is 45%. Okay, as you can see for the cumulative version, this is a probability at the end, so don't forget the value that you will find here should be between 0 and 1. You cannot find more than 1 or negative values for here. Or let me also give you another example, like cumulative 1.5 and 0. What about this one? As you can see, we are dealing with integers here, but this is not impossible because we are talking about the cumulative version. It means that whatever which is less than 1.5 for x, it means that this one is included and this one is also included. But for y, we are talking about only this part. So these are the, actually we should show it like these two cells. These two cells should be included. So this one, please also write the complete solution, like showing what are the probability mass functions as well. So here we are dealing with 0, 0, and also 1, 0, okay? So here the probability at the end for this cumulative version should be 15% plus 10%, which is 25%, is the final answer. 20%, 25%. Okay, so be careful about this. If it was the lowercase, it was a different story. Let's say if it was lowercase, like I ask you, what's the probability of this one? 1.5, 0. Then this one is equal to 0, okay, because it's impossible. But in case of cumulative version, we are considering less values as well, or even equal one. There is no equal, no problem, but there are some less values like 0 and 1. So we had to consider them. This is tricky at the beginning, but if you practice, you will get it. So please go through these two items that I talked about very carefully again and again so that it will make sense for you. And it needs practice, otherwise you may confuse it again in the future. So please go through them carefully. All right, next one, question number 4. Obtain the marginal probability mass functions for x and y. So the probability distribution that we have given you is joint one. It means that x and y together. Now we are asking about the marginal probability mass function. So how to do that? It means that first of all, check the summation of each row and column so that you know what's going on for y and x. Then you can construct each one of the probability distribution. So if y is equal to 0, then what's the probability of that? It will be, or maybe right away I show you for both x and y so it will make sense for you instead of calculating them. So this is the probability distribution for x, this is the probability distribution for y. For each one of the probabilities for x, you can consider first with the capital and lowercase, also here the same. For y equal to y. So what are the possible values for x? 0, 1, 2. For y, we have 0, 1, 2. So the next thing to do is to just fill these parts, right? For each one of them, we should find the probability. So for x, what should I write? I should find what is the probability of x equal to 0. So it means that find the summation of when x, all of them are equal to 0. Doesn't matter what's the value of y. So one by one for each intersection we should check, and I showed you in one of the slides in the lecture. So please make sure that you watch the lecture number 2 before going through this tutorial. Otherwise, it doesn't make sense now. So it should be 35, 45. So for whenever x is equal to 0, what's the probability? This is 45%. What about 1? This is the summation of these three together. So it should be 30%. What about this one? 2, it should be 25%. Then check whether the probability distribution that you have constructed is true or not. First of all of them should be probabilities between 0 and 1. This is true. And the summation should be equal to 1. Is it the case if I calculate their summation? So 55% plus 45%, yes, this is 1, this is true. So this is a probability distribution. And what about y? Now it's easy, just you got the idea. So if y is equal to 0, then the summation of all of them together. So 30%, 40%, and 30%. Again, this is a probability distribution. All of them are probabilities, and the summation is 1. So here we are considering the columns, okay? All right, what about next questions? You already know how to obtain marginal probabilities from joint probability distributions. That's good. Now, is the number of inquiries during the first hour independent of the number of inquiries during the second hour? Or in another word, are X and Y independent events? Justify your answer. It means that show us why this is the case. If you say they are independent, why? And if they are dependent, then what's the reason? Okay, as I suggested before, first look for a counterexample. If you don't find counterexample for all of the cells, then they are independent. But to find counterexample when this is not the case for independency, it's very easy. And for example, here I pick 0 because it's very easy to show. Or even you could choose this one, but doesn't matter for each one of them. Maybe if you find some equalities, you should continue until you reach the place you find the counterexample. If not, if for all of these 9 possibilities they are equal, then that's not the case. But when I say equal, what do I mean by that? There's a formula for that. Do you remember? That for each one of these probabilities, we should reach the same. It means that X, for each one of these Xi's, this probability should be equal to, and by the way, here I should show Y equal to Yi. The multiplication of these two should be equal to the joint probability. At the same time, it should happen. Okay, the formula is also given in the slides for the lectures. Also, you can use f function instead of using such terms. I don't remember whether in lectures I showed you in this format or not, but anyway, you should provide the formula for that. This is also a correct formula to provide for the discrete case. Okay, so this formula we should check for independency, whether they are equal or not for all of I and J. So here it's better to consider J, not to be confused with I, because not always they are the same, okay? So now the formula completed. So what is I, what is J? I can get its values from 0, 1, 2. For J, this is the same. But not always this is the case. In one example in the lectures also we showed you, not always they are the same. Okay, now this one could be a counter example, or maybe not, we should check. So for the case of I equal to 2 and J equal to 2, I want to check whether this is a counter example or not. And when I check that, I see if 0 is equal to, now you should find the marginal ones. So what's the probability of Y equal to 2? This is 30%. So the summation of this one and this one and this one, 30%. And what about when x is equal to 2? What's the probability of that? 5%, 20%, so 25%. So when you multiply them, is it equal to 0? It's very clear that this is not the case. You found a counter example. So 0 is not equal to 30% multiply 25%. So you should say that x and y are not independent. So by finding a counter example, that's the way to show it. But in case if x and y are independent, you should show for all of the 9 cases the equality holds. So that's the way to write the final answer if x and y are independent. So for all of them, you should have such equality. But as soon as you find one counter example, then you show it like this. For example, 0 is not equal to this one, and this is the general formula. And by that, I showed that the x and y are not independent. Okay. It was the case for independency for discrete joint probability distributions. What about question number 6? Compute the expected value of x, Ex. How to calculate this one? Ex. Do you remember the general formula? Please check that. It means that for each one of them, you use x multiply the probability of each one of them. So it means that you should consider xi's multiply by probability of capital X equal to xi. That's the way we can find it. So it means that for each one of them, x equal to 0, x equal to 1, x equal to 2, you should find these values. For xi's, it can get its value from 0, 1, and 2 anyway. So for example, what's the probability of x equal to 0? The summation of these 3 cells together, okay? And usually when you receive a probability distribution, it's nice that you show the summation of each one of the rows and also columns in order to make your calculations easier later. But now I'm dealing with questions one by one just for practice. Otherwise, you can do it faster. Okay, so here 35, 45. Okay, 45. You remember in the lectures also I did it like this. I found the summations because they are the probability of each one of these marginal probabilities. Okay, 30% and 25%. We already also found the marginal distribution as well. Do you remember? Yes, this one. So this is a probability distribution that we have already found. By checking at this one, then you can also write the final answer faster. So now assume that I want to calculate it. Xi's is, for example, starting from 0, 0 multiplying its corresponding probability. So for 45% plus. Next one is 1 multiply the corresponding probability is 30% plus 2 multiply 25%. So what's the final answer for the expected value of x? This is, first let me check them one by one. Then this is 80%. Okay, you may ask me, is this value supposed to be always between 0 and 1? No, that's not the case. Expected value of x is not a probability. So this value that you find here is not necessarily between 0 and 1. It could be any value. By accident, it happened to be like this here in this example, but it's not always the case, okay? Be careful about that. What about expected value for y? Again, the same story. We should consider lowercase y and capital Y equal to each one of these lowercase one. Sorry that I write messy because of the mouse, but anyway, you got the idea. So here again, you need to find the summation of each of them. So you already know from this part, yes? So it should be 30, 40, and 30%. Okay. So here I have 30, 40, and 30%. So it's very easy again to find. So again, 0 multiply 30. If there are many cells, to make your job easier, you can put 3 dots, but usually we prefer to consider 2 components and then show the last component of that. So instead of 3 dots, it's better to write the whole thing, okay? Because at least we need to show 3 trends. So 1 multiply 40% plus 2 multiply 30%. So expected value of y is equal to 40% plus 60%, which is equal to 1. Okay. It could be even a value more than 1. There was no problem because, as I said, this is not a probability. This is an expected value. Okay, let's go through the next question. We are already done with 7, which was the expected value of y. Compute the variance of x. Okay. Let me at least do it for x. For y, it will be exactly the same procedure. So variance of x. What's the formula? Do you remember? As I said, please go through the lecture before going through this tutorial. Okay, the expected value of x power 2. These two are different and we explained in the lecture. So for this part, we have already calculated EX, right? EX happened to be 80%. And if I have any miscalculations, also let me know about them so I will announce to everyone. Because I didn't check the answers, I'm just doing it with you. But if you find any miscalculations, please let me know in the comments so I will announce to everyone. Okay, so EX has already been calculated. This part I have no problem. I just power it by 2 and that's over. But what about expected value of x2? Do you remember how to calculate this part? We talked about it in the lecture. It means that inside the formula, instead of x, now you have x power 2 multiply capital X equal to lowercase xi's. So it means that for each one of the xi's here, you should power it by 2. So we have 0, 1, 2. So 0 power 2 multiply the corresponding probability of x equal to 0, which you already know from each part. Again, you can take a look at the probability distribution of x so that you understand what is it very fast. So 45%. So next one, 1 power 2 multiply 30% plus 2 power 2 multiply 25%. Okay, so 30% plus, again, sorry for my messy typing, and this one is 4 multiplied 25%, which is 1, so the final answer is 1.30. So as you can see, here the value that you found is not necessarily between 0 and 1, which is no problem. Okay, so far we have calculated this one, but the question is related to variance of x. So here you should write variance of x is equal to 1.3. Don't power it by 2 again, because the whole thing that you calculated here is the expected value of x2, okay? So 1.3 minus, you already know what's the value of ex. This is 80%, and this one should be powered by 2, and you find the final answer, okay? So that's the way we calculate variance of x. For variance of y, this is the same procedure. Now instead of x, you have only y. That's it. Then you should deal with it by looking at the probability distribution of y instead of the joint probability of or x. But from joint probability, you already know how to create the whole thing from the beginning. Okay, so next question. For y, I told you this is very similar to x. So practice with it. If you have any questions, please let me know. The values at the end that you will find, they are not necessarily the same, okay? So compute covariance of x and y. Do you remember covariance formula? So for covariance of x and y, we should use this formula. This is equality, by the way. It's very hard to use the mouse for that. So equal to exy minus multiplication of ex ey. So expected value of multiplication of x and y minus multiplication of marginal expectations. So for ex and ey, you already know the values, right? We have already calculated them. So we should calculate this one. So how to calculate this one? Exy is equal to, so for each one of them, I need to multiply the value of xi multiply yj multiply by probability of xi yj. Okay, so multiplication of all of them together. So this is how you can deal with that. Let me write it here maybe. So forget about this part. Now exy is equal to, so starting from y equal to I equal to 0, j equal to 0. So 0, 0, and the corresponding probability, which is x equal to 0, y equal to 0. So in this case, 0 multiply 0 multiply 15%. So as you can see, this one is a little different, because you should take a look at the joint probability, not the marginal probabilities, to find what's the expectation of x and y, okay? So this one could be tricky. We should take a look at the joint distribution. So plus, now you just change the values for y or x. So let's say, for example, 0 and 1. So 0 multiply 1 multiply the corresponding probability, okay? So you should continue until the last cell. So 9 times here, because we have 3 possibilities for y and 3 for x. We should calculate it until reach 2 multiply 2 multiply 0, and then provide the final answer for this one, okay? And don't forget, what you calculated here so far was related to this. Then for covariance, you should multiply these two values together and then provide the final answer for the covariance, okay? So what I wrote here is related to expected value of x and y. Then for covariance, you should use this formula. You already found ex and ey, and easily you can find the final answer for the covariance. And you may ask me whether for covariance, can I get negative values? Yes, it's possible for covariance to get negative value. This is normal. And for does it have to be between 0 and 1? Again, no, this is not a probability. This is covariance. We talked about it in the lecture. Okay, the hardest question we can ask is related to correlation coefficient. Not because this is complicated, just because it needs calculations. So correlation coefficient, you already know from the lecture how to calculate them, right? So rho, which is correlation coefficient, and also you can show it, this is related to x and y, okay? Rho of x and y is equal to covariance of x and y. You already calculated covariance before in the previous slide, and square root of variance of x multiplied by variance of y. You have already found these two from the previous items as well, right? So you have all the information. For covariance, you know how to find it now. For variance of x and variance of y, then you find the final answer. What you should be careful about is that this value that you will find here, this one should be between -1 to 1 inclusive, okay? So if you find a value more than 1 or less than -1, it means that you made mistake in your calculation. This is a good test for you. So please go through the calculation carefully yourself. And if it is between these two values, most probably you did a correct one. But if it is not and you don't understand why you reached the wrong answer, please ask me your questions using email, or you can be online in the office hour and ask me your question. And for the office hours, please be on time if you have any questions, because I will allow students between, for example, if it is Thursday, so it will be between 4:30 to 4:50, 4:30 to 4:40. So if you be online during that time, I can let you in, then you can ask your questions. So if you be late, unfortunately, I will leave the session soon. And that's why it's very important to be on time if you have any questions. If you don't, then you don't need to participate. You can also ask me your questions using email. Okay, guys, see you in the next lecture.